I'm a cell biologist and I'm interested in how cells adapt to their environment, and especially the low oxygen environment, which is called hypoxia. What we want to understand is how cells sense and understand the low oxygen environment and react to it. So for example, we have shown that if cells are cultured in hypoxia for several days, then they become resistant to the chemotherapeutic treatment. This is true in brain tumors, in adult brain tumors and in pediatric brain tumors. So to understand the aggressive behavior of cells which are cultured in hypoxia, we have used neuroblastoma cells. So this is a pediatric tumor which occurs in young children, and Anne has been working for several years on how cells adapt to oxygen and change their metastatic properties. So what she has shown is that if we culture the cells for more than 3 days in 1% oxygen, then they become aggressive and they can invade in other parts of the body. So what does that mean? It means that from the primary tumor, the cells will be able to detach, to migrate toward the blood vessels, and then once inside the blood circulation, they will have to go out of the circulation and invade in a tissue and grow a secondary tumor. This is called metastasis. And this, when we pre-culture the cells in hypoxia, we enhance these metastatic properties of the cells. So how has she demonstrated this? She has labeled the neuroblastoma cells with fluorescent markers so we can see them when we use an in vivo model, and then she has pre-cultured the cells in hypoxia or not. The cells are then implanted in a chick embryo model, so it's an egg where the chick embryo grows, and above this chick embryo there is a membrane which is called the choriolentic membrane. This membrane is like the placenta in humans. We can put the cancer cells there and they will grow as a tumors. If the cells have been pre-cultured in hypoxia, then not only will they form tumors, but they will also invade inside the chick embryo. So they will detach from this tumor, go to the blood circulation, and then invade in different organs of the chick embryo. And this only happens if the cells have been pre-cultured in hypoxia. For this preconditioning, we need to culture the cells for a long time in hypoxia, at least 3 days or even 5 days. And we don't want to reoxygenate them during this course of pre-incubation. So we use the hypoxic workstation, the H35, where we can manipulate the cells and also incubate them for several days. We need to split the cells to make sure that they don't overgrow, and we need to do this manipulation without reoxygenating the cells. This is why we use the hypoxic workstation. We have used this workstation for the past 6 years, and we've been able to use it to fulfill all of our requirements.